functions that can be graphed, not necessarily lines, but other types of functions. The first thing we're going to do, this is called piecewise functions. So you have f of x equal to, and you have several pieces. So you have 3x, for x less than -1, negative x for -1 less or equal to x less than 3, and then negative x plus 7 for x greater than 3. And what this means is you are going to be, the function that you will graph, you will have 3 pieces of different lines. You will have the line y equals 3x. You will have the line y equals negative x, and you will have the line y equals negative x plus 7. Then we're going to do domain and range. So let's graph all of those lines. The first line is y equals 3x. So you don't see your y-intercept, so it's through 0. And then you have rise and run of 3 over 1. You still have that line. You can probably barely see it. It's still there. The next one is y equals negative x. So again, we have a y-intercept of 0. And we have a slope. It says negative 1 over 1. So we're rising -1 and run of 1. So we have those two pieces of line, or those two lines, and we'll keep just parts here in a minute. And then the third line for this piecewise is y equals negative x plus 7. So here's our y-intercept of 7, and then we have a slope again, so it's going to be parallel to this line of -1 over positive direction of 1. So now we have these portions of the line that we're going to keep. So the first line that we graphed, y equals 3x, we are only keeping where x is less than 1. So we need to look at our x values. So along this line, when we get to x values of -1, we're keeping everything less than -1. So we look at all of that line less than -1. So we're keeping this portion of the line. The next line, y equals negative x, we are keeping from -1 to 3. So we look all through our x values, -1 to 3. And so along this line, we are keeping from -1 to 3. So we keep that portion. So we don't need the rest of the line. We're just going to darken in. My suggestion to you, students before, has been to graph this line as dotted, and then you can just darken in. And if you notice, -1 is or equal to, so that portion is darkened in, or like a closed circle. And then it says less than 3, so that's an open circle. And the same thing previously with the other line. It said less than -1, so this is open. And then finally, the third piece of the function was y equals negative x plus 7, and we're keeping from x greater than 3. So look along x where's greater than 3, and along this line where it was greater than 3 for x values. So we look greater than 3, and we're keeping that portion of the line, so to that right. And that is how you do a piecewise. And then domain, so look at all of these x values, look through here. So -1, along this portion, we did not have a -1 value, but then it picked up for this piece, and we did have -1. So it continues on this piece. We did have all of these values. Then we get here to -3, or get here to +3. There is no +3, no +3. Continues on this way. We have every real number, but we do not have 3, so that's not included. That's why it's not 3. And then we have graph. We have a graph piece. We have a graph as far as all the y values. We have nothing up here, so it is everything below 4. Then we have this strange thing called the greatest integer function, and we will practice that. Each decimal or mixed number has a greatest integer value of the previous integer, the integer less than or equal to x. So this is notation. It's got like a double bracket. So if you see f of x is equals this, and this is just exactly what it is. The only thing else that we could do would be like minus something or plus something. So here's your x value. This is for instance. So each thing that you can go in there. Basically what it is you can take any decimal number and the greatest integer, so what's the integer below this decimal, and remember negative's kind of a little bit weird. -3 is less than -2.6. For 4.5, the integer below that is 4. So what does that look like on a graph? It looks like stairs. So all of these decimal values, you have these little horizontal line bits, and it's equal to exactly the previous integer. All these decimal values before, but it will not equal to the integer just beyond it, because the next horizontal line piece takes your next greatest integer function. So we'll practice a little bit of that, and I just wanted you to see what it was, your notation, and then how you get that graph. And that is it, piecewise, and we'll have some other things that are step functions as well.